Bismillah ar-Rahman ar-Rahim. In the name of Allah, most gracious, most merciful. We continue to explain uh, automobile electrical and electronics subject. This lecture entitled Lecture 5 Charging System Part 1 for Automobile Engineering Department, Stage Number 4. Introduction. Upon completion and review of this chapter, you should be able to understand and describe the purpose of the charging system, the major component of the charging system, the function of the major components of the AC generator, the two styles of stators, how AC current is rectified to DC current in the AC generator, the three principal circuits used in the AC generator, the relationship between regulator resistance and field current, the relationship between field current and AC generator output, the differences between AC circuit, A circuit, B circuit, and isolated circuit. Also the operation of charge indicators including lamps, electronic voltage monitors, ammeters, and voltmeters, the use of the ISG and AC motors in hybrid electrical vehicles to recharge the HP battery, how regenerative braking is used to recharge the HP battery, means hybrid vehicle battery, the purpose of the DC-DC converter for charging the hybrid electrical vehicle auxiliary battery. Charging system is used to restore the electrical power to the battery that was used during engine starting. It is the vehicle's charging system that generates the current to operate all the electrical accessories while the engine is running. يعني الcharging system أو تسمى بالمصطلح العراقي الداينامو تستخدم اللي هي نفسها الالترنيتر or AC generator now اللي تستخدم لتوليد الطاقة الكهربائية أو التيار الكهربائي لكل ملحقات الكهربائية للماكينة أو الآلة أو السيارة. Two basic types of charging system have been used. The first was a DC generator, which was discontinued in the 1960s. Since that time, the AC generator has been the predominant charging device. يعني بالبداية استخدم DC generator والتيار DC، بعد ذلك استخدم ال AC generator وأصبح هو المسيطر في هذه الأيام. The DC generator and the AC generator both use similar operating principles. مبدأ عمل هذه الجنريترز نفس المبدأ الذي شرحنا عليه في المكائن والآلات الكهربائية، وقد شرحنا في المحاضرة السابقة في محاضرة ستارتنج سيستم الستارتر اللي هو نفس السلف، شرحنا أيضا مبدأ العمل، لذلك لا داعي لإعادة شرح العمل وموجود أيضا في هذه المحاضرة. The purpose of the conventional charging system is to convert the mechanical energy of the engine into electrical energy to recharge the battery and run the electrical accessories. When the engine is first started, the battery supplies all the current required by the starting and ignition system. The entire conventional charging system consists of the following components: battery, generator, drive belt اللي هو السير أو الحزام الناقل، هذا السير اللي ينقل الحركة الميكانيكية للمولد أو الداينامو أو الجنريتر. كل هذه الأسماء أو الألترنيتر، كل هذه الأسماء تعني جزء واحد اللي هو الداينامو والجنريتر. voltage regulator منظم فولتية، charge indicator مؤشر للشحن، عادة لامب أو جيج موجود على لوحة الداشبورد أو الدشبول مثل ما تسمى بالمصطلح العربي. 6 ignition switch، cables and wiring harness اللي هي الكابلات أو الوايرات الناقلة. starter relay subsystems، ليس كل الأنظمة تستخدم starter relay لكن أغلبها تستخدمها. fusible link subsystems أيضا اللي هي فيوز معين في حالة صدمة كهربائية، في حالة ارتفاع فولتية أو تيار، في حالة الضغط على النظام. الفيوسبل يعتبر نظام حماية إضافي. Principle of operation. All charging systems use the principle of electromagnetic induction to generate electrical power. Electromagnetic principle states that a voltage will be produced if motion between a conductor and a magnetic field occurs. The amount of voltage produced is affected by the speed at which the conductor passes through the magnetic field. Second, the strength of the magnetic field. Third, the number of conductors، يعني عدد الوايرات أو أجهزة التوصيل passing through the magnetic field. AC generators. AC generators التي هي شائعة الاستخدام في هذه الأيام. The DC generator was unable to produce the sufficient amount of current required. يعني لماذا استبدلت؟ لأنه DC generator ببساطة was unable to produce the sufficient amount of current required when the engine was operating at low speed. With the addition of more electrical accessories and components, the AC alternating current generator or alternator replaced the DC generator. The main components of the AC generator are the rotor brushes, the stator, the rectifier bridge, the housing cooling fan. طبعا brushes ليست في كل الأنواع، الأنواع الحالية بدون brushless. The rotor creates the rotating magnetic field of the AC generator. It is the portion of the AC generator that is rotated by the drive belt. The rotor is constructed of many turns of copper wire around an iron core. There are metal plates bent over the windings at both ends of the rotor windings. Stators. The stator contains three main sets of windings wrapped in slots around a laminated circular iron frame as shown in figure below. The stator is the stationary coil in which electricity is produced. Each of the three windings has the same number of coils as the rotor has pairs of north and the south poles. The coils of each windings are evenly spaced around the core. The three sets of windings alternate and overlap as they pass through the core. The overlapping is needed to produce the required phase angles. The battery and the electrical system cannot accept or store AC voltage. For the vehicle's electrical system to be able to use the voltage and current generated in the AC generator, the AC current needs to be converted to DC current. This process is called rectification اللي هي تعديل. السبلت أو تحويل، يعني إذا الأمور تسمى تحويل من تيار AC إلى تيار DC. A split ring commutator cannot be used to rectify AC current to DC current because the stator is stationary in an AC generator. Instead, a diode rectifier bridge is used to change the current in an AC generator. Acting as a one-way check valve, the diodes switch the current flow back and forth so that it flows from the AC generator in only one. AC generator circuits. There are three principal circuits used in an AC generator. First, the charging circuit consists of the stator windings and rectifier circuit. Second, the excitation circuit consists of the rotor field coil and the electrical connection to the coil. Third, the pre-excitation circuit supplies the initial current for the field coil that starts the build-up of the magnetic field. For the AC generator to produce the current, the field coil must develop a magnetic field. The AC generator creates its own field current in addition to its output current. Regulation: the battery and the rest of the electrical system must be protected from excessive voltages. To prevent early battery and electrical system failure, regulation of the charging system voltage is very important. Also, the charging system must supply enough current to run the vehicle's electrical accessories when the engine is running. AC generators do not require current limiters because of their design. They limit their own current output. Current limit is the result of the constantly changing magnetic field because of the induced AC current. As the magnetic field changes, an opposing current is induced in the stator windings. The inductive reactance in the AC generator limits the maximum current that the AC generator can produce, even though current amperage is limited by its operating voltage is not. The AC generator is capable of producing as high as 250 volts. If it were not controlled, regulation of voltage is done by varying the amount of field current flowing through the rotor. The higher the field current, the higher the output voltage. Control of field current can be done either by regulating the resistance in series with the field coil or by turning the field circuit on and off. By controlling the amount of current in the field coil, control of the field current and the AC generator output is obtained to ensure a full battery charge and operation of accessories. Most voltage regulators are set for a system voltage between 13.5 and 14.5 volts. يعني يقصد الاوتبوت اللي تطلع من الجنريتر يجب ان لا تتعدى 13.5 and 14.5 volts. The input voltage to the AC generator is called sensing voltage. Field circuits. To properly test and surface the charging system, it is important to identify the field circuit being used. Automobile manufacturers use three basic types of field circuits. The first type is called the A circuit. It has the regulator on the ground side of the field coil. The B positive for the field coil is picked up from inside the AC generator. By placing the regulator on the ground side of the field coil, the regulator will allow the control of field current by varying the current flow to ground. The second type of field circuit is called the B circuit. In this case, the voltage regulator controls the power side of the field circuit. Also, the field coil is grounded from inside the AC generator. Second, the excitation circuit consists of the rotor, field coil, and the electrical connections to the coil. Third, the pre-excitation circuit supplies the initial current for the field coil that starts the build-up of the magnetic field. For the AC generator to produce current, the field coil must develop a magnetic field. The AC generator creates its own field current in addition to its output current. Thanks for attention. Any question you can text